Welcome back to Easy Concept. Today we are going to start TRB Polytechnic 2017 question paper. Okay, so this is the 2017 TRB question paper analysis for civil engineering. Okay, we are going to see first question. In the standard penetration test, SPT is carried out in a sandy soil below the water table. The water level in the borehole is always maintained. So the answer for this question is A. The water level in the borehole is always maintained above the groundwater level. Okay, suppose this is the borehole. In that borehole only the standard penetration test will be done. Okay, this is the borehole and this is the ground. That is bottom of the borehole. Okay, now what it says, the water level on the borehole shall be as high as possible. That is water level in the borewell. This is the borewell. Water level in the borewell is greater than or above the groundwater level. Okay, so suppose the groundwater level is somewhere here. This is the groundwater level, groundwater table. This is the water table in borehole. Okay, so in order to do this standard penetration test, you have to keep the water level in the borehole is as high as possible. Okay, now we will see some of the points which is around this standard penetration test, that also important for your examination. Okay, see some more points under standard penetration test are first one about standard penetration test. So the first point is sample diameter. They maybe ask you this diameter. The inner diameter is 38, outer diameter is equal to 40 mm. This is 38 mm. Okay, and the second point is the weight of the hammer. Weight of hammer used for the standard penetration test is 65 kg, and height of fall of this weight is 75 centimeter. Okay, this is the important point. Next one is measure SPT number. Measure SPT number corresponding to 450 mm penetration. 450 mm penetration. Be careful. Out of this 450 mm, we can divide this 450 mm into 2. We can divide this 450 mm into 2. One is first to 150 mm. That is the blow which is required for seating the borehole. Next one is a 300 mm. So this 150 mm, the reading we will not take. This 150 mm reading won't take. won't take for calculation. Only the 300 mm reading shall be taken for our analysis. Okay, only this 300 mm reading shall be taken for our analysis. Okay, now the number of blows corresponding to this 350 mm is, we can call it as n. N is the number of blow which is required to cause a 300 mm penetration. Okay, so this is the standard penetration number value. Now in this there are two corrections. While taking this n, we have to take care of, there are two corrections. One is overburden correction. Overburden correction. Another one is a dye latency correction. Dye latency correction. So we can see first one is a overburden correction. Overburden correction. So overburden correction, N1 is equal to Cn into N. This N means N is getting from initial stage, that is in the initial. N is the number of blow corresponding to 300 mm penetration. Therefore, N1 is equal to Cn into N. We can write Cn is equal to 350 divided by effective stress plus 70, and this effective stress should not greater than 280 Newton per meter square. Okay, this is the first thing. The next one is dye latency correction. Here note, footnote, this overburden correction only applicable. Okay, that is, we can say not applicable for gravel. Not applicable for gravel. All other soils we can able to apply this. Second one is dye latency correction. Dye latency correction. What is a dye latency correction? We can say this is N2. Okay, N2 is equal to 15 plus N1 minus 15 divided by 2. And here note, always it is applicable N1 is greater than 15. That is, N1 means correction in overburden, right? So this dye latency correction is only applicable when this N1, after correcting the N value of overburden, the value is greater than 15, then only we can go for the dye latency correction. If it is less than 15, then we won't go for dye latency correction. And footnote, it is only applicable for sand and silt. Sand and silt, not for sand and silt, not for clay. Okay, so this is the important point. Now we can see the next question. The degree of disturbance of soil sample. The degree of disturbance of soil samples collected from the sampler is usually expressed by, the degree of disturbance is usually expressed by area ratio. The degree of expansion or contraction is expressed by recovery ratio. Okay, I can write here degree of disturbances expressed by area ratio. Degree of swelling and shrinking, that is shrinkage and swelling. Swelling expressed by recovery ratio. Okay, degree of disturbance is expressed by area ratio. Degree of shrinkage and swelling is expressed by recovery ratio. Okay, now here best option is B. Now we can see some of the points which is in area ratio and recovery ratio. Okay, so first of all, this very important examination question. I will give you the all points which is related to the area ratio. Okay, the first one is area ratio. Before that, we have to draw a sampler. So this is the sampler. Okay, a sampler. Okay, and this one from outer of sampler. This is the cutting edge. Okay, we can write this is the cutting edge. This is the sampling tube. And this is D1. This is D1, inner to inner distance D1, and inner to inner distance of sampling tube is D3. Outer to outer distance of sampling tube is D4. Okay, this is the schematic diagram of sampler. Okay, now we are going to write what is the area ratio. Area ratio which is equal to, we can write maximum cross sectional area of the cutting edge divided by maximum area of the cutting edge. See this one, D2. Okay, divided by area of the soil sample. So area of the soil sample which is passes through this hole, that is a D1 hole. Now area ratio which is equal to AR, we can write the formula D2 square minus D1 square divided by D1 square. So they will ask you this formula directly. So be careful, this formula directly they will ask you this equation. Okay, very important this. The next one is some of the points that we have to understand under the area ratio. Okay, that is, it should be noted that is area ratio should be kept as low as possible. Means possible lesser area. Okay, means cutting edge is short. Now, it should be kept less than 10 percentage, but in no case it should not exceed 20 percentage. So these two data are important. So to obtain a good quality sample, you have to keep the area ratio is less than 10 percentage. This is the factual data. But in no case this area ratio greater than 20 percentage. Okay. So these are the important points under the area ratio. Okay. Now another 2 points. This is the first one. Then in the sampler, next important point is inside clearance. Inside clearance. That is, we can say CI. The CI, which is defined D3 minus D1 divided by D1 into 100. So this is the inside clearance. Okay. Where we know D3 is the inner diameter of the sampling tube, and D1 is the inner diameter of the cutting edge. Okay. So D3 minus D1 divided by D1. Just now we can write inside clearance means inside clearance is meant to reduce friction between the soil sample and the sampler. So inside clearance is meant is used, which is reduce the friction between soil sampler and the soil sample and the sampler. So why this clearance is required? While the soil is entering within the cutting edge, it is under stressed where this area is less. So while it enters in the sampling tube, this area is somewhat more than this area, so that whatever soil which is coming in the cutting edge, that is easily goes through the sampling tube, because this size is somewhat more than this one, so it is easily passing through this sampling tube. The reason is the area is more. So the area is more, the friction also develop at the side of the sampling tube is less. Okay. So for this reason only we are providing some inside clearance. Okay. Between the soil sample and the sampler. Okay. When the soil mass enters the tube, it also permits elastic expansion of soil. This extra clearance, if there is a soil having any elastic property, then the elastic property will be take care of this clearance. So that clearance will allow the expansion of the soil. And this value, this is important, it shall be between 0.5 to 3 percentage. So this also important. This data they will ask you directly in your examination. This is the factual data. Okay. Next one is we can see outside clearance. So this is the inside clearance. Now we are going to see outside clearance. Okay. Outside clearance, that is C naught. So outside clearance is defined as D2 minus D4 divided by D4 into 100. See this portion is the outside clearance. Okay, this is the outside clearance. This is the outside clearance. Okay, into 100. Now, what is the use of this? It helps in reducing. It helps in reducing friction between sampling tube and soil when sampler is driven and withdrawn. While reading this statement, you can make sense. It helps in reducing the friction between sampling tube and the soil when the sampler is driven and withdrawn. See, when you driven this sampler within the soil mass to reduce the friction between sampling tube and the adjacent soil. Okay, to reduce the friction between sampling tube and adjacent soil, we are using this gap. Okay, see, so because of this gap, there is no contact between the soil and the sampling tube, but there was a contact between soil and the cutting edge. Okay, so the cutting edge is somewhat sharp in nature, therefore it can able to penetrate within the soil, but this is good end. That's why we are giving this much amount of gap so that the friction will be reduced easily. This sampling tube passes within the soil. Okay. Okay. Now this is the point. Now we can write it. What is the limit? It is kept between 0 to 2%. So this also important factual data. They will ask you in your upcoming examination. You can expect this data. Next important definition is a recovery ratio. A recovery ratio, that is LR. So LR, recovery ratio, is equal to a recovered length of sample divided by penetration length of sampler. This is the penetration length of sampler. This is the recovered length of sample. Sample means soil here. Okay, you can say soil. Here recovered means what? What is the meaning of recovered? Recovered means there are two meanings. Either swelling or shrinking. Right? So that is the thing. If there is no swelling and shrinking, then the penetration length, which is equal to, that is a penetration length of sampler and the length of the sample, both are same. Suppose, for example, this is your sampler which is inserted into the soil. Okay, Now, if these two, this is the penetration length of the sampler, okay, and inside the soil, this is the soil, the length of the soil sample also within the, that means the soil sample which was compacted or which was lies in the length of the soil, length of the sampler, then we can say the recovery ratio is 1. So we can write, if LR is equal to 1, then we can say good recovery. If LR is greater than 1, then we can say sample of swelled. If LR is less than 1, then sample of shrunk. What is the less than 1? That is actually the penetration length of sampler is more, but the recovered length of the sample is less. That means the soil is gets shrunk. That means this much is the length of the sample. Okay, this is the length of the sampler. Therefore, the value is less than 1. If it is a greater than 1, then the soil is lies, the length of the soil sample is above the length of the sampler. So therefore, numerator is greater than denominator, you will get a something like that value. LR is greater than 1, the sample of swelled in nature. Okay, so these are the points you have to keep in your mind. Why I have written? Because repeatedly, the last 2012 examination also, they have been asked the questions from this area ratio and recovery ratio. So repeatedly in all state government and central government examination, they are asking this sampler question: area ratio, inside clearance, outside clearance, recovery ratio. So you have to keep this in mind. Okay, so this is about the second question. Third question: the horizontal strain required to produce passive earth pressure condition in a cohesiveness soil. Horizontal strain required. So for that, answer for this question I am giving A. How it is A? See, there was a graph between stress versus strain, or denoting the stress. You know, this is the stress for active, passive, earth pressure at rest. Okay, this is the center point. So whatever point which is lies right of this graph, we can say this is the passive case. At the center, we can say this is the rest. At this point, we can say this is the active. This ordinate, we can say this is the Ka, coefficient of active earth pressure. And up to here, we will say this is the coefficient of the earth pressure at rest. And this one we will say this is coefficient of passive earth pressure. Okay. Now, from this, the right side, wall movement towards the soil. The left side, wall movement away from the soil. Away from the soil. That means wall movement towards the soil, then your passive coefficient is more. Once the passive coefficient is more, then the passive earth pressure is more. Okay, we know that the passive earth pressure PP, which is equal to Kp into sigma B. So now we understood from that the stress is more. Okay, we know that also Also we know that stress is in general directly proportional to strain. If the stress is more, then the strain also more. So the horizontal strain produced or horizontal strain required to produce passive earth pressure. To produce a passive earth pressure, this one we need more strain. We need more strain as compared to active case. In the active case, we can write as a passive, so active earth pressure is equal to Ka into sigma B. Here Ka is less as compared to Kp. Therefore, strain required to produce active earth pressure is somewhat lesser than the strain required to produce passive earth pressure. So therefore, we need a more. Understood? So that is a thing. And also you have to keep in your mind what is a Ka. 1 minus sine phi divided by 1 plus sine phi. Kp, which is equal to 1 plus the reciprocal of this divided by 1 minus sine phi. Ka into Kp, which is equal to 1. Then another one, earth pressure at rest in terms of Poisson's ratio mu divided by 1 minus mu. One more formula, K naught is equal to 1 minus sine phi for cohesionless soil. For cohesionless soil. Okay, this also important point you have to keep in your mind for your examination. Okay, and in general I can write one more point. The coefficient of earth pressure sigma h dash divided by sigma b dash. This is the effective earth pressure. Okay, K is a coefficient of general. Okay, coefficient of earth pressure. So coefficient of earth pressure is equal to sigma h dash divided by sigma v dash. Now further this K is divided into 3: active earth pressure, passive earth pressure at rest. The general formula for coefficient of whether it's active or passive or earth pressure at rest, that is K. Then this K is further divided into 3: active, passive, earth pressure at rest. So you have to keep this also in your mind. Okay. Now next question. What is the allowable bearing pressure? Allowable bearing pressure is maximum pressure that can be applied on the soil to satisfy the requirements of A. Settlement, B. Shear, C. Both shear failure and settlement. Next one is none of these above. So answer for this question is both shear failure and settlement. So this is the answer. So I can give you the notes so that you will get some more idea. We know that foundation shall be safe in shear criteria and settlement criteria. Shear criteria and settlement criteria. So first of all, what is the safe load against shear criteria? Safe load against shear criteria. Safe load against shear criteria, we can write this: safe bearing capacity, safe load. Okay, safe load against shear criteria. Here safe bearing capacity into area of footing. Area of footing. Based on this, we will do. Another one is, second one is safe load against settlement criteria. Settlement criteria. Here safe bearing capacity, but here safe or allowable pressure. Allowable pressure into area of footing. Into area of footing. So answer for this is, take minimum of for design minimum of the two criteria will be taken or adopted. Okay, so take minimum of these two for design a footing. Now see this safe bearing capacity. This safe bearing capacity is the function of, it is a function of, depends upon soil strength. Yes, it is depends upon the soil strength, but the safe or allowable pressure is depends upon applied loads. Okay, now from that we understood the foundation will be designed both the shear and settlement criteria. Shear means safe bearing capacity in the area, you will get a safe load, or in the settlement means safe or allowable pressure in the area of footing, you will get a safe load. For designing, you have to take minimum of the two. Okay, so that now read the question. The allowable bearing pressure is the maximum pressure that can be applied on the soil by satisfying the requirement of shear condition as well as the settlement condition. The answer is C. Okay, next question. It's an interesting question. The total vertical settlement of a rigid foundation under a pressure Q is taken to be the dash times the total vertical settlement at the center of the flexible foundation. Choose the correct answer from the list below. Okay, now see, first of all, let me give a tabular column. Okay, so this is the value which is taken from IS 8009 part 1. Okay, this is influence factor for vertical displacement due to elastic compression as per IS 8009 part 1. So this was given for both flexible and rigid footing. Okay, so this is the flexible footing, this is the rigid footing. The flexible footing further divided into 3, that is center, corner and average. Okay, center, corner and average. This is the shape. First one is a circle. Second one is a rectangle. Rectangle, there are three values based on the L by B ratio. Okay, there are three cases. First one is 1, 1.5, 2. And we can write for first circle. For center one, for corner 0.64, the average is equal to 0.85. Take average. Rigid footing 0.8. And this is 1.12, 0.56, 0.95, 0.90, 1.36, 0.68, 1.2, 1.09, 1.53, 0.77, 1.31, 1.22. So this is the values. Now see, they are asking total vertical settlement. So total vertical settlement of a rigid footing, okay, under a pressure of Q is taken to be dash times the total vertical settlement at the center of the flexible footing. See here, this is the center. Okay, this is the flexible footing, this is the center. This is the rigid footing. We know that the settlement is equal to elastic settlement QB into 1 minus mu square into influence factor divided by Young's modulus of soil. This is the formula. We know that actually the total settlement is equal to elastic settlement or immediate settlement plus consolidation settlement plus plastic settlement. That is a secondary settlement. That is a final settlement, you can say. But for calculating this SC and SF, we need a elaborate discussion. That means consolidation settlement, we have a formula, and SF, we have a different formula. Once you know this SI, then you can conclude, okay, the settlement will be somewhat more, right? This is the immediate settlement or elastic settlement. This elastic settlement also comes into play with that comes into the picture of total settlement. For that, we are not taking into account now SC and SF, because SC and SF require more knowledge. So now we can analyze this question by using only SI, only by using SI. Okay, with that you can conclude. Now from this equation we know that SI, or I can write delta T is approximately SI equal to SI. This SI is directly proportional to influence factor, right? Influence factor. Now, what is the SI? That is SI for rigid footing. Rigid footing divided by vertical displacement of center of the flexible footing. That is for flexible footing center, which is equal to influence factor for rigid footing divided by influence factor for flexible footing at the center. Now see, there are so many centers are there. For circle 1, for rectangle, and different values are there. They did not mention what kind of footing we are having. Okay, now based on the options which is given, we can choose the best one. The rigid footing, the center values, if you take 1, okay, 1 divided by this one is 0.8. For circle center, for circle center is 1, for circle rigid footing influence factor is 0.8. Now we can write it this 0.8 times the settlement of rigid footing is equal to settlement of flexible footing at the center. So the settlement of flexible footing at the center is equal to 0.8 times the settlement of rigid footing at the center. So answer for this question is C. I hope you understood. Okay.